Hey everybody! We're going to spend some time today using our periodic table square to figure out exactly how many protons, neutrons, and electrons are in a given element's atom. Okay, so we can pick any element we want to for this example. Let's go ahead and pick carbon. Okay, carbon's an interesting element. It's actually in its simplest form, it's coal that we use to burn for our energy, but if you pressurize it, it turns into a diamond. So if I'm going to do a periodic table square that looks like carbon, I'm going to pull this information straight from our periodic table, and it's going to give me these four standard pieces of information as we've talked about in the past couple weeks. So let's go ahead and label what we know. This number that's up top, that's the smaller of the two values, is our atomic number. Then it also gives us another value or number, and this is our atomic mass. And when we're using, trying to figure out our numbers of protons, neutrons, and electrons, we're going to use these two numbers. Okay, that's going to be our key thing. Now, remember, we have to know which one is which. So you need to always remember that our atomic number is the smaller value. Don't get confused, because if you get these backwards, you're going to get all of these counts of these subatomic particles incorrect. So here we go. That was our review. We have our element picked. We remember which is the atomic number and which is the atomic mass. So let's move down here and let's say, how do I find the number of? And then we're going to start with protons. Okay? So how do I find the number of protons? Protons P plus. That's the first one I want to find out. So the protons are actually what give us the identity of the atom. It identifies it. So every atom in the whole wide world that has 6 protons in its nucleus is a carbon atom. Okay? So the atomic number is our identity as well. So how do I find the number of protons? It's actually equal to our atomic number. So if we're able to use the periodic table and figure out our atomic number, then we will know how many protons are in the nucleus of a given element's atom. So for our example here, carbon has how many? It's got 6 protons. Okay? So let's go down to the next thing. If we have 6 positive particles in our atom, we need to balance that out so that they're neutral. So we need to have 6 negatives as well. So let's remember, what are our negative particles called? Yep, that's our electrons. Okay, so E minus. So if we have an atomic number's worth of protons, our electrons have to be equal to our number of protons, which we know is also our atomic number. So carbon has 6 electrons as well. So far, so good, okay? They're just numbers coming straight from our periodic table. So now is where it gets a little bit more complicated. We have to find the number of neutrons. And let's not forget, our neutrons are signified by an N with a 0. So in order to find our number of neutrons, this is a little bit more complex in terms of the fact that it doesn't come straight from the square. You have to manipulate a number a little bit or change it. So let's go ahead and figure out how we do that. Now, if you remember from when we talked about atomic mass, all of the mass is in the nucleus, the center. Okay, and our nucleus has 2 types of particles in the nucleus. We have our protons in there, and we have our neutrons in there, right? So if all of our mass is in our nucleus, then that must mean that all of our mass is coming from our protons and our neutrons. And so how do we get the number of neutrons? Well, we take our mass, which is both of them, and we have to find a way to get rid of the protons so that we just have the neutrons left. Okay? So when we get rid of these protons, we can do that by subtracting the opposite of the addition. So we're going to take our atomic mass, but if you notice, our atomic mass has these 0.001, or it's got a some decimal number. So we want to make it simpler, and we want to round that. So our atomic mass rounded. And then we're going to subtract our atomic number. Okay, so for carbon again, how do I do this? I take my atomic mass, that's 12.001. I'm going to round down here because if we remember our rounding rules, it's 0.5 and above, give it a shove, 0.4 and below, let it go. So it's 0.4 and below, right? 0.0 follows the decimal. And so we're going to let it go. So we're just going to have 12. So atomic mass rounded is 12. And now we are going to subtract the atomic number, which we know is 6. So 12 minus 6, we find is also 6. So in this case, carbon has 6 protons, 6 electrons, and 6 neutrons. This is exactly the same process that you would follow for any element on the periodic table. So let's go ahead and give it some practice on our own now.